Hello everybody, welcome to my channel. Today we have a very good problem for you guys. We're going to be talking about max consecutive ones, three, right? So this is a very good one, so make sure you pay close attention to the problem, right? So given a binary array nums and integer k, right, return the maximum number of consecutive ones in the array if you can flip at most k zeros, right? So this is a very good one, as you can see, right? So a binary array, right, of zeros and ones, and we can flip at most k zeros into ones, right? And the ask is to find, right, the largest subarray that includes only ones, right? And some zeros we can flip into ones, right? And we can flip at most k of them into ones, right? That's why we have this integer k, right? So let's go through this example so we can further solidify the ask, what they're asking here, right? So the example one here, guys, right? You can see that we have this big array, right? And then you know what subarrays are. It's a subarray. That's a subarray, right? We have a lot of subarrays, right? So yeah, so it's an array in the array, right? Subarray, right? Yeah. So knowing that, right? We know what subarrays are. So we need to find a couple of them, right? We need to find the largest one though, right? That includes all ones, right? Okay. But we can flip some of the zeros into ones where we can afford to, right? So the k pretty much can tell us at the maximum number of zeros they can flip into ones, right? To help you to calculate the largest subarray that has only ones, guys, right? So you can see for this example, right, we flipped this zero and this zero, right, to get the maximum subarray of 6, right? So you can see 1, 2, 3, 4, 5, 6, where we have 6 ones, right? After flipping those two zeros into ones. And that's how we have that, guys, right? So let's go through example 2, right? I think will be similar, right? So you can see that it's a bigger array, right? And they're saying that we can flip 3 zeros into ones, right? So it's exactly what they end up doing, guys, right? They flip those 2 zeros into ones, right? And they flip this 0 into ones, right? Giving us a length of 10, right? After flipping those 3 zeros into ones, right? Yeah. So you might be tempted to say, right, why didn't they choose this one, right? It looks big as well, right? But this one is only length of 9, right? Let's say we flip those 3 zeros into ones, right? It still wouldn't be larger, right? Than, in this array right there, right? Which is of size 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This one is only of length 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You can see it's less, right? So, and we can't do this, right? It won't work because this means that we have 4 zeros in our and this subarray, which is not valid, right? We can have at most k, right? We can have 2, we can have 1, we can have 0 even, right? But we can't have more than k, right? That's kind of what this is, guys, right? So how do we go ahead and solve this problem, right? Easy way I'm thinking, right, is to just for every do a double fold, right? We know we love to start out with the straightforward solution, right? Double fold, right? For each index, we try to calculate the maximum subarray that it can uh, construct, right? With keeping in mind the constraint that they're giving us, right? Most k, right? So for index 0, we're trying to calculate the maximum subarray it can calculate, right? Starting at that particular index, right? And also at most k zeros in it, right? So we would just expand, for this index, right? And they have another for loop, right? That calculates. So expand, right? At this index, we can only do 5, right? Because we can flip 2 zeros, right? That's the maximum we can do, right? So we do that for every day. We start, this one, we try to calculate the maximum starting from there, right? You can see that it's not going to scale pretty nicely, right? It's going to be double fold, right? Squared. Ain't going to cut it, right? So we got to do a little bit better, guys, right? So we got to bring down the time complexity, right? How do we do that, though, right? So you can see that this problem kind of fits nicely into some of the problems that we've done, right? And we can see that we can use, right, some sort of a window type of approach, right? We know that we have different approaches here. We have setting windows where we have static window, like static sliding windows, and dynamic sliding windows, right? The static sliding window is where we have a fixed size of one window, right, which we slide over the array, pretty evenly, right? It's a constant, like, it's the static size, right, of a particular length, right? But for this one, right, it's much more of a dynamic sliding window, right? Because the window can be as big and as small as it can, like, as it wants, right? Depending on the input, right? So And we need to find the largest one, right? So that's whether it's a more like a dynamic one, right? Because we don't know what the size is at a time, right? So what we're gonna do, guys, right? That sliding window is gonna approach gonna be just like that, right? So we know that the right pointer, right, helps us to pretty much the sliding window is 2 pointers, right? So the sliding window, the right pointer helps us to slide and expand the window, right, and increasing the window. And then once we want to shrink it, right, we use the left pointer to shrink it, right? So we say, when do we need to shrink it? We need to shrink it when the window, right, that we have becomes invalid, right? And it becomes invalid when we have like the constraint becomes invalid, right? When we have at most k, we have more than k zeros in our current window, right? We need to somehow make it valid again, right? By shrinking the window, right? And until it becomes valid, and then we can move on and keep expanding, right? And we're not gonna keep expanding if the window is invalid, right? Because it's not gonna help us in calculating the maximum subarray that we want, right? It's not gonna be valid, right? It has to be valid. Okay, so how it's gonna work, guys? We're gonna use the right pointer to expand, right? And as we're expanding, right, we're gonna keep expanding until the window is still valid, right? We gotta keep doing it. And as soon as it becomes invalid, right, let's say for this particular example, right, it becomes invalid right there, guys, right? Then we keep shrinking it until it becomes valid, guys, right? So let's say the right pointer expands, now the length is 3. All right, we have 1 0, we have 2 zeros, right? So also one thing I want to bring up, right? We need to keep track of how many zeros we have, guys, right? So once it becomes invalid, right? Say we know we have a counter to help us to keep track of how many zeros we have in our particular window, right? We would expand, right? We have 2 zeros. The counter help us with that. We have 3 zeros, right? The counter is gonna help us with that, right? It becomes invalid, right? Then, right, we keep shrinking the window, right, until the counter that we have, right, is less than or equal to 2, right? So we keep so this will be our window, right? This is the window becomes invalid, right? Then the left pointer is going to shrink it, right? So now the window is going to be this one, right? Still invalid, right? Now the left pointer moves forward, right? Still invalid again, right? And then just keep shrinking it, guys, right? Still invalid, right? And then here will become valid again, right? After removing this 0, right? Which was, mixed and surplus, right? So now we have 2 zeros. Now we're still in this valid state, guys, right? And then we can keep expanding, right? Because see, we have 2, 3, 4, 5, right? So we have 5 zeros, right? Now we have 5 ones, right? Because we would flip those 2 into ones, right? And then we could keep doing that, right? We have 1, 2, 3, 4, 5, 6, right? We have like 6, guys, right? And then once we add this 0 here, you can see that we are in bad shape, right? It becomes invalid again, so we need to shrink. And now it's this array, right? And that's the array that we ended up choosing to be our largest one, right? So this is how it is, right? The right helps us to expand, and the left helps us to shrink when it becomes invalid, guys, right? So it's as simple as that, right? And yeah, so let's quickly go ahead into the code. I think it'll make even more sense if you guys just follow through. So we have our left pointer, right? And so this is the starting order of our window, right? That we have, okay? And we have this for loop, right? That's gonna help us. And so the right pointer is gonna help us to expand, right? So before we get into that, right, we said that we needed a counter for the number of zeros that we gonna have in our window, right? Help us to keep track of that, right? And then also we're gonna need the maximum, right? So we can check the maximum subarray, the large subarray we've encountered while doing the algorithm, right? So we're gonna have a right pointer is gonna be less. Start at 0 as well, right? The right pointer is less than num_ln. Right plus plus. Okay. So now we're gonna check, right? You're gonna do a simple check here. If the number, right? The number that the right pointer is pointing at is equal to 0, right? Because we need to remember that we need to keep track of how many zeros we have in our current window. Okay, that's very, very important, right? Okay. So now after we do that, right, and then we're gonna, so remember that it needs to be valid, right? The window, right? So if it becomes invalid, right? So we're gonna keep shrinking the left the window until it becomes valid, right? So we have a while loop, right? So while the left pointer is less than num that length, just a simple check, make sure you're staying bounds, right? And right, the number of zeros, right, is greater than k, right? We're gonna keep incrementing, right? So if it's greater than k, then we kind of keep shrinking, right? Keep shrinking as much as we can. And here, guys, we're gonna do a check here, guys. If nums the left, right, is equal to 0, right? Then we're gonna reduce the number of zeros that we have in our window, because this is, we're not accounting for that zero anymore in our window. So we can decrement the number of zeros that are included in our particular window, because I told you guys, right, that's what that thing represents, okay? Okay, now that we have that, what's next for us is to just get the max, right? The max is going to be that max of what? Of the maximum or the length of the current valid window that we have, right? That's where we do this first, right? To make sure that it's a valid subarray, right? That fits the constraint that we're given, right? You can see that, this is a template code that we use in a lot of the other problems, right? It's the same thing, right? The logic here is only the difference depending on the problem that you're doing, right? It's very similar to the problems that we've done, guys, right? And that's why it's good to understand those patterns, because it can help you to solve a lot of different problems. Okay, so let's press run code. Okay, there's one thing I'm missing. I meant to do minus here. It's my B, so we need to decrement the thing, right? So simple mistake. All right, press submit. Awesome, guys. We're about to pass all the test cases, guys. Right? If you guys found value, you guys enjoyed this video, let me know that in the comment section. If you're new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to really thank you guys for watching, and yeah, and I'll see you guys in the next video.